Hello, Mr. LaBeouf, with another video for the 8th grade Algebra 1 students about quadratic functions and completing the square. I take this exact question from a student who asked me about it from IXL, and it appeared this way: s squared plus 16s equals 15, and you were asked to solve this equation by completing the square. First thing I want to say is I don't know why math publishers, whether it's textbooks or online, use letters other than X here. Of course, the letters X and Y, where we name the X and Y axes for graphing, and when we write out functions, f of x equals y equals some function involving x. Those letters X and Y are arbitrary, but everybody uses them, so why confuse things with S's? So you're going to have to deal with that with IXL, but at least for now, let's just make this look more reasonable as x squared plus 16x equals 15. All right. Anytime you have a quadratic equation, you have to realize that it is associated with a particular quadratic function. What is the quadratic function here that this equation is associated with? We'll sort of back up a little bit, and you would see that it is f of x equals y equals x squared plus 16x minus 15. And at this point, I want to say something else. Desmos.com. When you're working on quadratic functions, hopefully you have two devices, or you could tab and be doing IXL, and also at the same time look at the graph on Desmos.com. I taught Algebra 1 for about 10 years without having Desmos.com available to me. I don't know how I survived. It was a much less interesting experience for me and the students to not be able to see the graph that we're doing the algebra about. So take advantage of the technology. I've drawn an extremely crude graph here of this function. It's extremely crude, but you can look at a nice graph of the function in Desmos. Please do that all of the time. Now, if we want to find the two places where the graph of this function crosses the x-axis. The x-axis is where y, or the f of x, is 0. So we set the function equal to 0, x squared plus 16x minus 15 equals 0. We might want to note here that this trinomial cannot be factored. That's often the easiest way to solve a quadratic equation, is by factoring, but that's not available here. So we're going to complete the square. And completing the square has one or two preliminary steps. This one only has one because the a is 1. If the a is something other than 1, you'd have a second preliminary step. But the only preliminary step here is to get the negative 15 on the right by adding 15 to each side. And that's what you were given, only it was s's. So they've done the first preliminary step for you of completing the square. Now you're ready to complete the square. You take half of the 16 and square it and add that to each side. Okay, easy. Now this is an even number. If this had been odd, it would be a little harder, because when you take half of an odd number, it's not an integer. But what we want to add to each side here is, of course, 64. Half of 16 is 8. Square it to get 64. We have to keep an equivalent equation to the one we started with. So we have to add 64 to each side. The left side is now a perfect square trinomial. That's why this is called completing the square. We just created a perfect square trinomial. We're going to factor it as x plus 8 squared. And that 8, that plus 8, is the half of the 16 that we just did. So this becomes x plus 8 squared equals, the right side now is 79. By the way, the fact that that 79 is not a perfect square goes along with the fact that this trinomial could not be factored. You'll If you don't see that now, you will as we go forward. At this point, there's just what I'd like you to see as an automatic reflex. When you have a number squared equals a number, in this case, the number being squared is x plus 8. The x plus 8 is going to be plus or minus the square root of 79. Now, that 79 was not a perfect square, but it is positive. The fact that that 79 is positive means that there are going to be two real roots, two real zeros, two real values of x that will make the function's graph cross the x-axis, and I've drawn the crude sketch of it here. To finish now, we're going to simply subtract 8 from each side and get x equals -8 plus or minus the square root of 79. So we have to follow both paths, -8 plus the square root of 79 and -8 minus the square root of 79. And if you look on Desmos, the two values of x that cause the graph to cross the x-axis are given as 0.888 and -16.888. If you want to get a calculator out right now and come up with an estimate for the square root of 79, of course it's going to be a little bit less than 9. The square root of 81 is 9, the square root of 79 is a little less. And if you take an approximation for the square root of 79 and do -8 plus that, well, you're going to get this. You're going to get the 0.888. -8 plus the square root of 79 is approximately 0.888. You should confirm that for yourself with a calculator. And then when you do -8 minus the square root of 79, you'll get this one, -16.888. I guess is the calculator giving you for an approximation of the square root of 79, is it 8.888? I think that's it, right? And when you add -8 plus 8.888, gives you that. And -8 minus 8.888 gives you that. So it's cool. It's very cool. Make sure you have the experience of confirming what you see geometrically using Desmos with what you get algebraically, and quadratic functions are wonderful. Please enjoy them. Bye-bye for now.